Hello, this is Sal. In today's video, we will be configuring VLANs and a little bit about VOIP. I hope my videos are helpful for those who are seeking to be certified for the CCNA and the CCNA security exams. If you like my videos, please subscribe to my channel and recommend it to your friends and share it and give me the thumb up. And please, let me know if you have any suggestions, comments, or questions. I will gladly answer you back. On the description of this video, you will find two files. One for PackTracer source files and the documents to walk you through the lab step by step until you finally will be able to verify configurations you did during this lab. The VLANs, virtual LAN area networks, are helpful in the administration of logical groups, allowing members of a group to be easily moved, changed, or added. In today's lab, we'll focus on creating and naming VLANs and assigning access ports to specific VLANs. I will issue a command on switch 1 that displays all VLANs configured by default. And as we will see here on switch 1, enable show VLAN. As you can see here, we have 5 VLANs installed by default on the switch default. This is 1 and these 4, so 5 VLANs by default. We will notice that all interfaces, as you can see on the switch, all the interfaces on the switch, we have 24 ports for the fast Ethernet and 2 ports for the gigabit Ethernet are under the VLAN number 1 by default. All the ports on the switch, on any given switch. This is how it comes from the manufacturer. Let me shrink this a little bit. Now, next, I will verify connectivity between the PCs on the same network. As you can see here, we have PC1. It's on the network of 192.168.10.0/24, but it is VLAN. We will configure it later under VLAN 10. But this PC here, PC1, and the PC4 here, they are both in the same network. And as you noticed that all the PCs now under, by default, even the ports here connecting the switches together, these, and the connection between the switches and the PCs, all by default under VLAN 1. So now, I will verify the connectivity between the PCs on the same network, and we will notice that each PC can ping the other PC that shares the same network. So here on PC1, I already configured the IP address with the subnet mask for the PC. So we will go to under command prompt, and here I will ping 192.168.10.11. And here, because both are on the same network, so we were able to ping from one PC to another, and yet also the connection connecting the PCs to the switches to the switches are all by default under VLAN 1. So now also I will ping from PC2. Here this guy can ping PC5 because both are in the same network, 192.168.20.0/24. So go to PC2, and also here I configured the IP address for it. So under command prompt, ping 192.168.20.21, and the same with the PC3. So let's keep this in mind for later. I'll point something out here, ping 192 and also PC3 was able to ping PC6. Now, if I try to ping from PC1 to PC6, it would fail. This PC1, I will ping this guy here on 192.168.30.31, ping 192.168.30.31. It would fail. Why? Sure, they are within the same network. They are by default under VLAN 1, but they are in different. Each PC is connected to the switch under like this PC6 is connected to switch 3 under VLAN, by default VLAN 1, but they are both in a different network. So PC1 was not able to ping PCC because PC6 is under the network of 192.168.30.0/24, and PC1 here is the network of 192.168.10.0. Here we have advantages of VLANs, as they provide a number of advantages such as ease of administration, confinement of broadcast domains, reduced broadcast traffic, and enforcement of security policies, and also enable logical grouping of end stations that are physically dispersed on a network. Now, I will create and name VLANs on switch 1. So back to switch 1, configure terminal. On switch 1, I will create VLAN 10 and give it a name of admins, VLAN 20, users, VLAN 30, guests, VLAN 99, management, and VLAN 150 for voice for the PC here, and we will do the configuration later on this lab. So here on switch 1, VLAN 10, we will name it admins. VLAN 20, give it a name of users. VLAN 30, give it a name of guests. And VLAN 99, give it the name of management. And VLAN 150, and this we will name it voice. Let us verify now what we did so far. Show VLAN brief. As you can see here, that is showing us that we created VLAN 10 for admins, 20, 30, 99, and 150. But still, the ports on the switch are all in the default VLAN, which is VLAN 1. So I'll do the same. This command, the command I ran here, show VLAN brief, this displayed for us the VLAN name, as you can see here, the status and the associated ports on the switch. Nothing on the VLANs is configured of these ports. They are still under the default VLAN, which is VLAN 1. So I'll do the same on switch 2. Enable, configure terminal, VLAN 10, name it admins, VLAN 20, users, VLAN 30, guests, name guests, VLAN 99, we will name it management, and VLAN 150, and this guy we will name it this VLAN as voice. Show VLAN brief. So to see what we did so far. And as you can see, everything we configured is listed here. So now we will do the same on switch 3. Enable, configure terminal, VLAN 10, name admins, VLAN 20, users, VLAN 30, name guests, VLAN 99, name this VLAN management, and finally VLAN 150, as we will name it as voice. Also, let us check out what we did so far. Show VLAN brief, and everything is okay so far. Next, I will assign VLAN to ports on switch 2 and switch 3. I will configure the interfaces, these interfaces connecting the PCs to the switch as access ports, and assign the VLANs as follows. For VLAN 10, this port here, Fast Ethernet 011, VLAN 20, Fast Ethernet 018, and VLAN 30 for Fast Ethernet 06. So back on the switch, configure terminal. Now, interface F011, switch port mode access, switch port access VLAN 10. This is for this port here, F011. With this PC, this is under VLAN 10. Now for the other interface of F018, switch port mode access, switch port access VLAN 30. Now I will assign, this is 18, I'll do interface F06. I did a mistake here, so I'll go back. This interface F018, no switch port access, no switch port access VLAN 30. For switch port access VLAN 20. Interface F06, switch port mode access, switch port access VLAN 30. Exit, exit, show VLAN brief. Let me see if that corrected the mistake. So for VLAN 10, F011, for the users, VLAN 20, F018, and for the guests, F06, and everything is okay. Now I'll do the same on switch 3. We all could possibly, when we are working on a lab or do a configuration, even real life, maybe you'll do mistakes. It's about, how you can reverse this mistake and correct it. You need to catch it, Now on switch 3, configure terminal, interface F011, switch port mode access, switch port access VLAN 10, interface F018, switch port mode access, switch port access VLAN 20, and port of F06, switch port mode access, switch port access VLAN 30, and show VLAN brief, and everything is Okay, the configuration we did as we planned to. And you know, in real life, just or even when you are working on a lab, you know, just whenever you do a step, just verify with the show command, so you will not, if there is a mistake, you will not keep do, you know, just you do a configuration on the network device, just double check your work. Okay, now I will assign a voice, the voice VLAN here on this port to F011 on switch 3, as you can see in the topology diagram here. The switch 3 Fast Ethernet 11 interface connects to a Cisco IP phone and PC4. The IP phone contains an integrated 3 ports 10 and 100 switch. One port of the IP phone is labeled switch and connects to the F011, and another port on the IP phone is labeled PC and connects to PC4. The IP phone also has an internal port that connects to the IP phone functions. The switch 3 F011 interface must be configured to support user traffic to PC4 using VLAN 10 and voice traffic to the IP phone using VLAN 150. The interface must also enable quality of service and trust the class of service, the QoS and the CoS values assigned by the IP phone. So now back to switch 3, and we'll do the commands like this. Configure terminal. Now on the interface, connecting the switch to the IP phone interface F011. Now I will configure a quality of service. MLS stand for multi-layer switching. So the command goes like this: MLS quality of service question mark. Here we want to trust CoS keyword. Enter. Here we'll say switch port voice VLAN 150. So we are done with the configuration. So let's verify what we did so far. Show VLAN brief. And as you can see here, for VLAN 10, it's for data and for the PC, and VLAN 150 on the same port F011, as you can see here also at the same port F011, this is for voice. Now let's verify loss of connectivity. Previously, as I pointed before, the PCs that share the same network could ping each other successfully, as I pinged from PC1 to PC4 with no problem. Both are in the same network, the same with PC2, and the same with PC3. Well, we were able to ping PC6, but when we tried to ping from PC1 to PC6, it didn't work. Why? Because they are in different networks. Now, but the PCs on the same network, we were able to ping each other successfully. Now let's try to ping between PC1 and PC4. Even though the access ports are assigned to the appropriate VLANs, let's see if the ping will go through. Here on PC1, let's do the same and ping PC4. Ping 192.168.10.11. The ping failed. Why? Because the ports between the switches are in VLAN 1 by default. The ports are in VLAN 1 by default, like gigabit 01 and here on switch 1, and the same with on switch 2 and on switch 3. By default, these switches, if I will run this command on switch 1, show VLAN brief, as you can see here, this is on switch 1. I'll do this on switch 2. Show VLAN brief. As you can see here, now between switch 1 and switch 2, they are connected via gigabit Ethernet 01 and 01 here, and both, as you can see here, by default under VLAN 1, we have giga 01 here on switch 2. It's still in a different VLAN. Before we were able to ping because all the PCs were under the same VLAN, which is VLAN 1, and they were on the same network between like PC 1 and PC 2. But now, when we try to ping, we configured PC 1 here under VLAN 10, which is different than the switch connecting switch 1 and switch 2, which is by default still under VLAN 1. And the same here with the PC 4. Before, when we were able to ping between PC 1 and PC 4, both PCs were, or the connection were still under the default network, which is VLAN 1. But now, PC 1 and PC 4 under VLAN 10, PC 2 and PC 5, they are under VLAN 20. Like if I try to ping from PC 2 to PC 5, ping 192.168.20.21, it will fail because the connection between the switches is still under the default VLAN, which is VLAN 1, and the PCs are in a different VLAN. So as you can see, the ping failed because the ports between the switches are in VLAN 1 by default, and PC 1 and PC 4, or PC 2 and PC 5, or PC 3 and PC 6 are in VLAN 10, 20, and 30, as we assigned them. And how to solve this problem? We can solve this issue and make the PCs able to ping each other. We should configure the ports between the switches with the trunks to permit activity. So this is all what we need to configure the connection from PC switch 1 to switch 2 as a trunk, and from switch 2 also on this port must both talk the same language in order to allow the traffic to go through them as trunk, to trunk the traffic from the PCs on the same network to go through. So that's it for today. I hope you learned something from this video. Please, if you like it, subscribe to my channel and give me the thumb up and share the video. And if you have any comments, please leave me a comment and I will answer you as soon as possible. Thank you so much for watching, and I'll see you in my next video. Have a nice day.